Hello! In this video, we'll explore important concepts with MinIO, a cloud-native object storage system that's fully open source. You can check out the documentation at min.io, and the source code is available on GitHub under a very permissive license. Two key concepts in MinIO are storage tiers and lifecycle policies. Storage tiers allow us to connect to other storage systems, such as Google Cloud Storage. This means we can offload data to cheaper cloud storage options, even while running a local MinIO instance. We get the best of both worlds and can precisely define where our data is stored within this tiering strategy. For example, we might use a long-term tier in Google Cloud Storage for infrequently accessed data, while keeping a short-term tier locally for more frequently accessed data. Let's start by creating a new Google Cloud project. We'll set up MinIO on Kubernetes Engine, which is one of the simplest ways to deploy it. Even though we're using Kubernetes Engine for this demonstration, these concepts should apply equally well to other MinIO runtimes. Once the Kubernetes API is enabled, let's create a Kubernetes cluster. For simplicity, we'll opt for an Autopilot cluster using all the defaults. An Autopilot cluster allows Google to take care of the node pool design and management for us. With the cluster up and running, we'll use Cloud Shell as a quick and easy way to provision a MinIO instance onto this cluster, utilizing the IDE capabilities. Let's briefly discuss what's in the YAML file we're using. Networking resources for MinIO that provide access to the MinIO console, the GUI where we manage MinIO, the deployment itself, which uses the official MinIO Docker container, environment variables specifying a root user, and a persistent data volume for MinIO data. Let's open a terminal and deploy this YAML resource with the kubectl apply. What we care about most now is network access to log into our MinIO instance. Let's check the networking resources to ensure everything's working correctly. Initially, we see 0 out of 0 backends healthy. Let's double-check our service configuration. The MinIO console service uses a selector of app MinIO. We're exposing port 9090, the console port, and this is set as the default backend for our ingress. Wait a moment. There we go. We now have 1 out of 1 healthy. Our URL is set up and we're making progress. We just need to wait another minute or two. Let's grab our login URL. Note that we're using HTTP here, so be cautious. This isn't suitable for production environments. Next, we'll create a bucket. Buckets are where we store objects, similar to services like S3 or Google Cloud Storage. Now we can navigate to the object browser and upload files. For instance, we could take a quick screenshot, then drag and drop that file in. It's that simple. What we'd like to do now is use Google Cloud Storage as a backend for some of this data. Let's create a bucket in Google Cloud to demonstrate this concept. Imagine we want to use extremely cheap storage options like archive or cold line storage, which are significantly cheaper per gigabyte than running storage ourselves. We'll leave most of the defaults in place, except we'll disable the soft delete policy. Now we have our cold line bucket set up. Back in MinIO, you'll notice features like user identity management and monitoring. While there's plenty to configure, using the MinIO CLI is the most powerful way to set up our tiering. So we'll exec into the MinIO instance and start running commands. First, let's ensure our MinIO instance is authenticated to use the local tier. Now you can see our demonstration bucket we created earlier. Let's add a new tier using the MinIO command line interface. In our lifecycle management, we'll add a GCS tier, Google Cloud Storage, to our local instance, and we'll call this GCS. Our bucket is named MinIO tiering. We'll use the prefix data, so all the objects we upload to this remote tier will be prefixed with data, similar to a folder structure. Next, we need to provide a credentials file and set the storage class to cold line. The credentials file is needed to authenticate with the bucket, and MinIO will use a service account for that. Let's navigate to the Service Accounts page in our Google Cloud project and create a new service account named MinIO. We can assign the roles here or apply them at the bucket level. For simplicity, we'll assign the storage admin role at the project level. While this is a bit excessive, it suffices for our demonstration purposes. Next, go to the service account keys and create a new key. It will automatically download, and we'll use it in our MinIO command. Let's open another terminal and place our JSON key there. Be very cautious. If anyone gets a hold of this key, they can access all the buckets and data in your project, including the ability to create and delete buckets. Always keep this key secure. Before copying it into the MinIO container, let's rename the key file. Since tar isn't available in the MinIO container, we'll use a workaround. We'll print out the key and save it during our exec session. Let's see if that works. And it works. Now we'll provide the key.json file in our command. Don't forget to include the credentials flag for the credentials file. All right, we should be good now. Our remote tier is now configured to send data to Google Cloud, specifically to the MinIO tiering bucket with the data prefix. You might notice there's nothing in the Google Cloud bucket yet. That's because we haven't configured MinIO on when to use this bucket. Let's fix that together. While still in the MinIO container, we'll execute another MC command to add a lifecycle policy. We'll set it to transition objects to our Google Cloud Storage class immediately after 0 days. We'll specify our MinIO instance and the bucket. Now, if we navigate to the data prefixed path in Google Cloud Storage, which is automatically generated, and open the file, we'll see our MinIO screenshot that we uploaded earlier. We've successfully transitioned it to Google Cloud Storage. The file isn't even on the MinIO server anymore. Yet, if we try to download it through MinIO, it still works because MinIO pulls it from the remote storage and hosts it locally on demand. As you move towards production, consider global availability using multi-regional buckets, enforcing least privilege permissions, and exploring cost optimization and lifecycle policies on the Google Cloud side. Also remember that network costs can add up when transferring large amounts of data between these services. If you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. We'll include all code and the diagram file in the description as well. If you have any questions, please post them in the comment section and we'll do our very best to respond. Thank you very much for watching to the end, and please enjoy responsibly.